Now let's take a look at our key concept. Remember that the area of a two-dimensional composite figure is the sum of the areas of all the shapes that compose it. So the area of this two-dimensional shape is made up of adding the areas for shape A, shape B, and shape C to get a total area. The same thing goes for finding the surface area of a composite figure that is three-dimensional. So in this case, we need to add the areas of each face of the prism, but not the face that is shared. So you'll notice here in the figure that there is a space right here where shape B connects to shape A. That's the area of the shape that we do not need to include in the surface area because it's not visible from the outside of the shape. So to find the surface area of the entire figure, we need to find the individual surface area of shape A, the individual surface area of shape B, and then add them together to get the surface area of the entire composite shape. Don't forget that you need to know and be familiar with finding area of figures. So area of squares and rectangles can be found by doing length times width. Okay, so on any rectangular or square figure, length times width. If you have a shape that is a triangle, remember, triangle is a base times a height. And then you have to take half of that. So 1/2 times the base times the height. Okay, if you have a triangle that looks like this, the height may be drawn inside the shape, but the base is still that area or that space, that side on the bottom. Now I'd like for you to try number 5. Number 5 can be made up of 3 shapes. You see 2 triangles, and then you see 1 large rectangle. See if you can find the surface area of this shape. And let's take a look. The area of the 2 triangles can be found by taking half times the base, which is 2.5, times the height, which is 8. And 1/2 times 2.5 times 8 equals 10. Since there are 2 triangles, we need 10 times 2 to make a total area there for the triangles of 20. The rectangle, on the other hand, we only have one of those shapes. So the area of that rectangle is 7.5, which is this dimension here, times the total length of that rectangle, which is 13, plus 8 more, or 21. That's where this 21 comes from, because this entire side right here is a total length of 21 centimeters. And that is 157 5/10. And then to find the total area of the entire composite figure, you need to add those 2 areas together. So 157 5/10 plus 20 makes a grand total area of 177 5/10 square centimeters. Next, let's take a look at question 7. Jacob is putting tiles on the sections of his yard labeled A, B, and C. What is the area of the parts that need tiles? So when we look at this diagram, we need to consider what the dimensions are for the rectangle A and the rectangle B and the triangle marked C. We can do that and then find the area of each piece and then put the pieces together to find the total area of the yard that needs the tiles. So take a look at the dimensions for rectangle A. Part A has dimensions of 3 meters by 6 meters. So 3 meters by 6 meters gives you an area of 18 square meters. Then let's take a look at the rectangle that is marked B. So this one is a little bit trickier because none of the labels on the diagram show us anything about the dimensions for part B. What we do know is that part B here has this side, and you'll notice that if you go over here to the edge, it lines up here with the mark that ends the 3 meters along the triangle C, but the rest of this also has a height that we can gauge from other information. If we know that the entire yard is 6 meters and this piece of it over here on the right side is 3, then that means we have to have 3 meters along that second piece. So one dimension of rectangle B is 3. Then we need to determine what the length of rectangle B is, okay? And we can do that if we know the other parts. So notice in A that we have 3 meters across the top of A, and we also have another 3 meters along triangle C. So the piece that we're missing here is this piece in the middle, okay? And we can get that piece by doing some addition and subtraction. So for example, down here at the bottom, do you see this 7.5 meters? Okay, that takes us right here to the edge that lines up with the top part. So 7.5 along the bottom, this piece right here also along the bottom is another 3 meters, which means the total distance across the yard is 10.5 meters. Well, if that's the case, then I can take out the 3 meters up top on both sides, which makes 6, take away 6, and that means that bottom piece for part B has to be 4 5/10 meters. So that dimension is 4 5/10. Okay, and now you need to multiply 3 times 4 5/10 to get the area of part B. So that area is 13 5/10 meters squared. Oh, there we go. All right, now we need to look at part C. So this triangle looks like an isosceles triangle where each of those two sides, the length or the base and the height are both 3. And we need to take half of that. So half times 3 times 3 is 4.5. Okay, 3 times 3 is 9. Half of 9 is 4.5. So then the total areas, put those numbers together. So 18 plus 13.5, 13.5, plus 4.5, or 14.5. And what does that equal for the total area of parts A, B, and C together? And that gives us an area of 36 square meters that need tiles. The last question we're going to try is number 16. The bottom part of this block is a rectangular prism. The top part is a square pyramid. How much paper is needed to completely cover the block? Explain. So remember, in order to find the amount of paper, we're looking for the surface area. Since there is a piece inside, actually 2 faces of that figure inside the figure, so the base of the pyramid, okay, that's this piece that you see here, and the top of the rectangular prism are connected together and they are inside the figure. So we will not be finding the area of those faces of the figure, just the faces along the outside. So let's take a look at what we have along the outside. Okay, if you start with the base, okay, which is the rectangular prism block, you have each of them with dimensions of 4 centimeters across and 3 centimeters tall. So we have a front and a back and a left and a right side that are all the same. And all of them are 4 by 3 rectangles, which is 12. And then we have 4 of those. So 12 times 4 faces equals a total area of 48. Then we also have the bottom of the figure. Okay, the bottom is a little bit different because it's not a rectangle anymore. The bottom is actually a square. This piece right here is a 4 by 4 square. Which is 16 square centimeters. Then we need to move on to the top. Okay, the top is the pyramid, and it also has a square base. So that means that this edge right here on all 4 of the triangular pieces is 4 centimeters. And the height of each of those triangle pieces is 6 centimeters. So I have a total of 4 triangles that are all the same. And out of those 4 triangles, we have an area of 1/2 times the base, which is 4, times the height, which is 6. Okay, so 1/2 times 4 times 6 makes an area of 12. And you have 4 of those triangles. Okay, actually let's do that in blue. 4 of those triangles. So then let's do 12 times 4 to make 48 for the area of the triangles. And we have 48 for the faces of the pyramid. And then we also have the bottom, faces of the prism. And we also have the bottom, which is 16. So to find the total surface area, which is how much paper we need to completely cover the block, we need to add 48 plus 16 plus 48. And what do you get for a total surface area? And this is going to be in centimeters squared. I'm going to go back to black here. So 48 plus 16 equals what number? So the grand total surface area for this figure is 112 square centimeters. Now you're ready to try some practice problems on your own.